circular motion actually, but few more points we will discuss on friction. There is a sentence, friction is a necessary evil. Friction is necessary evil. Friction is important, but it is bad also. Correct or not? So what do you mean by this? Okay. So see, it causes wear and tear. It causes wear and tear. Okay. Wear and tear. T-I-E-R. Wear and tear of bodies. Okay. Bodies or object. The machine parts, machine parts are rotating, sometimes sliding. Okay. So two surface slide against each other. Correct. So that causes wear and tear. So like for example, there is a knife. How do you sharp your knife? Suppose this is the knife. How do you sharp it? You have to rub it against a solid hard surface, correct? Like this, because it is causing wear and tear, correct or not? But to make knife sharp, you have to slide it against rough surface. Then small bits of metal will be removed from the knife, correct? So then it will be sharp, correct? So it is a good thing. Friction is good thing here. Similarly, suppose very cold winter is there. Very cold winter is there. How do you get heat like this? Correct? So you this hand, you slide against each other. So heat is generated, right? Heat is generated because you are doing work. You are doing work. So that work is converted into heat. So heat is generated, correct? So it is good thing. Friction is good thing here also. Correct? It helps in walking also. Friction helps in walking. Can you walk on a smooth floor? We cannot walk on a smooth floor, correct? See how. So how do you walk? Suppose you see, suppose these are the shoes. Okay. Now this person want to go. So what this person will do? Now this is the surface. This is the smooth surface. This is the smooth surface. Correct. Now person want to go right side. Now just imagine this chair. This chair cannot go right side. You have to push it, right? You have to push it. So this person want to go right side. Is there someone pushing it from behind? No, there is no person here. And it is a smooth surface. Correct. So this person cannot go right side because only force it can experience is normal upward and mg downward. Correct. So normal upward can take it up. So it can jump. For jumping also, it needs normal force. Correct. Suppose this person want to jump. So it will push the ground downward. Okay. So ground will push it upward. You have seen, suppose a person want to jump. First it will sit. Correct or not? The person will do like this. Now person is jumping. First it will push it, then jump. Correct or not? Now it is in air. Correct? Pushing. So how it is getting force? How it is getting force? It is getting normal force. See, it is using its own energy. It is using its own energy to push the ground downward. Understood? So ground is pushing it upward. So this is how it jumps. But walking means you need rightward or leftward force, correct? Suppose you want to walk right side. So in which direction you need force? Right side, correct or not? So anyone here experience here exerting force? Is there anyone here? No. So this person cannot walk. Okay. the person can move the leg. Suppose person move the leg, it will slip. The legs will slip here like this, and whole body will fall. Okay? Whole body will fall. The person will look like this. Okay, understood? If the person slip, the person will fall but cannot walk. Okay. So for walking, what is needed? Friction is needed. So how? See how the surface is imperfect. Correct. Rough surface is like this. This is rough surface, and the person is also standing. This is the person. Now the shoes. Okay, legs of the person. So this legs of the person. Now you see the surface hill. This is known as hill of surface, and this is known as valley of shoes or legs. Okay, valley of shoes. So this is a person surface. This is person surface, and this is a ground surface or floor or road surface. Okay, so it is a rough surface. So it is not horizontal. If you see using microscope, you will see it is not horizontal. So this surface will push this surface, correct? So this surface will also push this surface. What is the direction of this force? It is vertical, horizontal, or inclined? Inclined, correct? So two components are there. Vertical component. I'm talking about this force, okay? So this force has two components, vertical and horizontal. So vertical is giving what? Normal. Vertical is giving normal. And horizontal is giving friction. So this is the friction. Okay. So the person is pushing the floor this way. So floor is pushing the person this way. Horizontal component is friction. Okay. So that horizontal force is exerted by what? Who is exerting this horizontal force? Floor. Correct. Very good. So the person will walk right side. Okay, understood? Person will move right side. So for walking, we need force because you want yourself, you want your body to move. So you need external force. So this floor is external to the body. So floor is exerting force. Okay, so this is the friction force. Understood? Now suppose you are running. Now you want to stop. You are running and you want to stop. So this is the hill of the surface and this is the valley of your shoes or legs. Okay, leg. Okay, understood? So you will push this hill this way. So the hill will push you this way. Now what are the components? Vertical component will be upward, horizontal component will be leftward. And where is your motion? Your motion is right side. Understood? So the friction is acting where? Left side. Okay. So this friction will accelerate you or retard you? Retard you. Okay, because this friction is acting opposite to motion. Okay, so this will cause deceleration. Okay, this will cause deceleration. You have seen if you go to any small kids classroom like class 1, class 2, in the break time kids are running, correct? So suppose one kid is there standing, how in which direction friction will act? Suppose that kid is just starting running. What is the direction? Suppose kid want to go right side. Right now standing. Right now go want to go right side. Friction will act where? Right side. Correct. Friction will act right side. Suppose you want to start from rest. Start from rest. Now the same kid. Now same kid acquire some speed. Now it acquires some speed. Now want to stop it. So now what is the direction of friction? Now want to stop it. So left side. So friction is acting left side. Okay. Friction is acting left side. So when you run on the road, when you speed up, friction is helping you. Are you getting or not? Helping you to speed up. So friction is accelerating you. Now you want to stop it. You want to stop. Okay. Again friction is helping you to stop. Are you getting? Can you stop on ice floor. This is ice floor, and this is rough. Suppose here to here, A to B it is rough, and B to C it is ice floor. Now A to B you are running, A to B you are running. So friction is helping you. After that, no friction. What you will do? Can you stop? You acquire some speed, maybe 10 meter per second speed you acquire. Now, can you stop here? Ice floor? No, because ice floor is smooth. Okay? Ice. So you will maintain your speed. You cannot stop. Okay, you will maintain. You will slip. You will slip. Understood? You will slide. So to start running and to come to rest, to stop also, in both cases friction is needed. Okay, so that's why we cannot walk on smooth floor. For walking, what type of floor is needed? Rough. Okay, rough floor is needed, like this floor is rough. Okay? Rough floor is needed. Now let's talk about uh, how. Okay, one more example. You see, this block is there. I want this block to move right side, like this. What is the direction of friction? Tell me. I am exerting force right side. So what is the direction of friction? Left side. Correct. So motion is right side. Motion is right side, but friction is left side. Correct. This is one example. Block. Block is moving right side because of this force. So friction is acting left side. So friction is opposite to motion. Friction is opposite to motion. Now one more example you see. Suppose there is a car. This is a car or truck or trolley. This is a trolley. Now there is a block inside and the floor is rough. This is a rough floor. Okay. So now this car is on the road and acceleration of the car is right side. Acceleration of the car is right side. Okay. Observe carefully. This is the trolley. You can call it truck also. Truck or trolley. Acceleration is right side. Now can you tell me what is the direction of friction force on this? On the box. Find direction of friction force. Find direction of friction force on box. Suppose it is at rest. Inside the truck it is at rest. So this observer is inside the truck. So this observer is non-inertial, correct? It is accelerating. So according to this observer, this object is at rest. So what is the free body diagram? Suppose this observer is A. Okay. So with respect to A, with respect to observer A, what is the direction? What are the what are the forces? Free body diagram. Acceleration of truck is where? Right side. So pseudo force will be where? Left side. So pseudo force is equal to ma. So this box will slide left side, but it is not sliding. So friction is acting where? Right side. So friction is acting right side. Understood? So according to A, box is not moving. Box is not moving, correct? According to A. Suppose you are in a train. You are in a train. Train is accelerating. Speed is increasing, like metro train. Generally, which train you see acceleration? Normal train, our normal big trains are there. They speed up slowly, right or not? They start like this, very slow. Then slowly pick up speed. But metro train, you have seen metro train, they pick up speed very fast, correct? If you want to observe a metro train, Chennai is there, or where? Madurai. Bangalore. Okay, once maybe you have seen already. Just observe when you sit in metro train. Just observe the speed, how it is. Speed is increasing. Okay, so acceleration you see there. Speed is increasing very fast. Okay, so acceleration is right side. So all passenger will slide where? Left side. But the floor is what? Rough, sufficiently rough. So this box is not sliding. Why? Because friction is acting where? Right side. Okay, so what type of friction is there? Tell me. Is it sliding on the surface? No, it is not sliding on the surface. It is not sliding. So what type of friction? Static or kinetic? Static friction. This is static friction. And direction is right side. And motion is also right side. Motion is also right side. Now another observer is there. B. B. According to this observer, you tell me. According to B. B is at rest. This is on road. This observer B is standing on the road, and it is seeing that trolley is going. It is seeing that the trolley is going. Okay, according to B. You can call it tree. It is a building. Okay, pole, electric pole, building, tree. So tree, building, these are at rest. So this trolley is going right side. So what about box? Suppose it is a transparent window, all transparent window, glass. It is made up of glass. So B can see this. Okay. So what B will see? Tell me. The block is moving or not? Huh? According to B, block is moving or not? Moving. Very good. According to A, block is not moving. According to A, block is not moving because A is where? Where is A? Inside the truck. Okay, train, truck, car, whatever, bus. So what type of friction B will observe? Static or kinetic? No. So it is static only because B is observing this surface also. B is observing this surface also, floor of the bus, and this box also, and B is observing that the box is not sliding on the surface. For B, it is not road. With respect to road, this block is moving. But what is the surface in contact with the block? Road or floor? Floor. So floor is in contact with the block. Okay. Floor of bus or truck or trolley, bus, truck, floor of bus, truck, trolley is in contact with the box. Is there any relative motion between floor of bus and box? Is there any relative motion? No. So it is static, whether from observer B or observer A. Okay. So box is not moving. Box is not moving relative to floor of trolley. Relative to floor of trolley. So with respect to A and B both. So with respect to B and A, friction is static. Friction is static. Are you getting? Friction is static. Okay, understood? Remember, kinetic friction means sliding is compulsory. For kinetic friction, what is compulsory? Sliding is compulsory. Sliding is must. If there is no sliding, so what is the friction? Static. You will see that the object is moving. So object is moving, it doesn't mean friction is kinetic. Okay? Object is moving, okay. Object is moving. According to B, truck is moving. Box inside the truck also moving. It is made up of glass, window. All outside person can see it. Okay? So, but with respect to this surface, floor, it is not sliding. Okay? Understood? So that is kinetic or static friction? Static friction. So according to B, what is the direction of motion of box? Right side. And according to B, what is the direction of friction on box? Right side. Okay. So so friction is always opposite to motion. True or false? False. In this case, suppose this is the observer. According to this observer, what is the direction of motion? Right side. Friction. Left side. Now this friction is static or kinetic? This is kinetic. This is kinetic friction because sliding is there. Okay, like this. This is sliding. This is sliding. Understood? Suppose I am walking like this. I am walking like this. Okay, you observe. Now I am walking like this. What is the difference? When I do like this, what is this? Sliding is there. Correct or not? When you do like this, it is sliding. But now sliding is there or not? There is no sliding. I am just putting my leg and removing. Putting my leg, removing. There is no sliding like this. Understood? So what type of friction is acting right now on me? What type of friction? Static or kinetic? Static. So it is static. Okay. So note down. When we walk, when we walk, you have seen school, primary class, class 1, class 2, small kids, they run, they make noise also. What teachers tell them? Don't make noise, right? Walk correctly. Correctly walk means what? This is correct walk, correct? This is correct. But if a student is walking like this, that is what? Sliding. It will make noise, correct? Sound will come. So that's why teacher scold them, right? So when we walk, just put a leg and remove. So it is static friction. It is static friction. So what type of friction is helping to walk? Static or kinetic? Right now, static friction. Okay, clear? And how we are walking, that I have explained. Okay. Ah, yes, tell. Correct. True. Friction always relative motion between the two surface in contact. So I am writing that friction always oppose, friction always oppose relative motion of two surface in contact. So this is always true. This is true. Okay, note down. Friction always oppose relative motion. Friction always oppose relative motion. True or false? True. So walking also relative motion. See, suppose you want to walk. Now you will say that you are walking right side. So how friction is also right side? Friction should be opposite. When sliding is there, like this box is there. Suppose box is moving right side. Now it is sliding. So friction is where? Left side. But walking is not sliding. I am walking. Is it sliding? No. No, this is not sliding. This is sliding. Okay, like this. This is sliding. So suppose this person want to go right side. So what this person will do? It will the hills and valley, you know, hills and valley. This is the This is the surface of person legs, okay, person legs, and this is the surface of road. This is the surface of road. So person surface valley will push the hill. This is known as hill, correct? Hill, and this is valley. So valley will push the hill where? This way. So hill will push valley where? This way. Now this is the force on the person. It has components. So this horizontal component is where? Right side. So person will go where? Right side. So this is friction. Okay, this is friction force. Understood? So this is friction force. Okay. Suppose you are in ice floor. Suppose you are in ice floor. Ice floor means what type of surface? A smooth surface. You are lying in it like this. You are on the ice floor. And there is a ground here. This is the ground. This is the ground. How you can come to ground? But there is no other person standing. How you can come? Tell me. You cannot walk. You cannot walk. How you can come to ground? But ice is very smooth. It is very smooth. No friction. Frictionless. Ice is frictionless. How you can come to ground? Tell me. Think. Okay, I am giving you one more help. Suppose you have a ball. You have a ball. Okay. You are standing here and you have a ball. You have a ball. Football. Now, how you can come to ground? Any idea? Tell me. Okay, think. Think like forces. You throw the ball this way. You hold the ball and throw it that way. So you are exerting force on the ball where? Right side. You are exerting force on the ball where? Right side. Force on ball. This is action. This is action. So person will experience force left side. That is reaction. Understood? So friction is not there. Friction is not there. Frictionless. So this person will slide where? Left side. And ground is there. So person can come to ground. Understood? Are you getting or not? So suppose ball is not there. Suppose the person has any object, maybe cloth. It can be cloth also. It will throw the cloth this way. So this person will experience force where? Left side. Whatever object it has, whatever object that person can throw, it can be shoes also. It can be shoes also. Whatever object this person has, it should throw it where? This direction. So it will experience force where? Person will experience force where? Left direction. So person can slide. Are you getting? Tell me. Okay, clear? Okay. Now suppose you don't have any object to throw. Now how you can come? Still you can throw something. Air. You can throw air. Blow air. Okay. So if you throw air from your mouth you throw air here. Okay. So air is experiencing force where? Right side. So you will experience force where? Left side. Same thing happens with rocket also. How rocket is going up? It is ejecting gases where? Where it is ejecting gases? Up or down? Down. Rockets eject gases down. So force on the gas is where? Down. So force on rocket is where? Up. Understood? Action reaction. So this is action, this is reaction. gases are experiencing force downward, so rocket will experience force upward. So without friction you can move. Understood? On ice floor you can move yourself without friction. You have to throw something. Anything you can throw. Whatever you can throw, you throw it. Right side. So your body will move where? Left side. Okay. Let's do one more example. Pole. Pole and man. Pole and man. You can note down this topic. It is a good question. See, this is a pole. This is a pole. Okay. And there is a person here. This person is getting ready for going to army. Okay. Or police or some Olympic. Okay. I am asking this person to go and climb this pole. I am asking this person to climb the pole. To climb pole. Okay. How it is possible? You have seen any person climbing the pole? Like I'm not talking about tree. Perfectly like this pole like this. Okay. It is not tree. Tree means branches are there. It can hold branch. Okay. And climb. But this is a pole. There is no nothing. No branch is there. Okay. So what will help this person? What should be surface? What type of surface? Rough surface. Very good. So it will hold it. First it will hold it. Correct. So this person will hold it like this. These are the hands. These are the hands of the person. Correct. So person is holding it. Correct. Then person will exert force on the pole downward. Are you getting? So pole will exert force on the person upward. Now hills and valleys are like this. Okay. Like this hills and valleys. So this is the person hand. This is the person hand and this is the pole surface. This is the pole surface. Understood? Like this. This is the pole surface, this is the person hand. It will hold the surface like this and it will push it like this. This person will push it like this. So friction. Understood? So what is the direction of friction? Tell me on the person. Upward. So friction is acting upward. Okay, clear? So friction is acting upward. So suppose friction is F, mg is downward. So how will you find acceleration? F minus mg is equal to ma. Friction is acting upward. Mg is downward. Which should be greater? F friction or mg? Which is greater? Friction should be greater. Are you getting? A person is very lightweight, 40 kg, 30 kg. Then mg is less. So friction is also less. But heavy person is there, 90 kg, 120 kg. So mg is more. So friction is also more. So if you want more friction means what is more? What should be more? What is the maximum value of friction? What is the maximum value of friction? Normal. Mu s into normal. So heavy person is there. So it needs more friction. More friction means more normal. So how you are getting normal here? You have, so heavy person should hold the pole more firmly. More. Are you getting or not? More tightly like this. Okay. Light person softly also it is holding. Okay. But heavy person more tightly it will hold the pole. Understood? So like this. Suppose this is I am holding lightly, softly. But now it is more tightly I am holding. Are you getting? Softly. So more tightly you are holding, normal will be more. Are you getting? So what is the direction of normal? Tell me. You are holding the pole. What is the direction of normal? Correct. It is horizontal. Normal is horizontal. Okay. Suppose I right now, what is the normal? Suppose I am holding like this. What is the direction of normal? This way. Now I am holding like this. What is the direction? Here. What is the direction normal here? All direction normal is there. Correct. Correct. So that if you hold tightly, normal is more. Softly, normal is less. It can slide very easily. Tightly I am holding, it cannot slide. Okay, because normal is more. So we can solve one question. You write down one question. Vertical pole, vertical pole has mu s value pointed. Person of mass 80 kg want to climb the pole with acceleration g by 3. Person of mass 80 kg want to climb the pole. Okay, hold the pole like this, climbing. Okay, so climb the pole with acceleration g by 3. Acceleration g by 3. Find normal force exerted by pole on person. What is the minimum normal force? Find minimum normal force exerted by, find minimum normal force. See, you have to hold, you can you all are having pen, right? You can try it. Hold the pen softly. Now hold the pen tightly like this. What is difference? What is difference? You are holding it softly and now you are holding it tightly. What is the difference? Normal force. Normal force. Understood or not? This surface, hand, this is what you call palm. What you call it? Palm. Okay, you're holding it like this. So softly I am holding. Easily it can be removed like this. See? So normal is less. Normal force, all the contact points are there. Contacts where contact is there. Normal is less. Now I'm holding what? Tightly. Now you cannot remove it. See? It cannot remove because tightly I'm holding. So normal is more. More normal. So tell me, what is the direction of normal? If pole is vertical, what is the direction of normal? Horizontal. Very good. Normal is like this. Okay. So you can draw free body diagram like this. This is the normal. This is mg, and friction is acting up. And normal is in all direction, not one direction. It is in all direction. Horizontal. Normal is horizontal. This circle, I have drawn one circle, right? What type of circle is this? It is horizontal. This is horizontal plane. This green color I have drawn here, that is horizontal plane. So you are holding a pole like this. You are holding a pole like this. You are holding pole like this. Okay. So what is the direction? So you are holding a pole. Okay, clear. So horizontal. Okay. So here contact is there. So one normal here. Now here also contact is there. See. So one normal here. Now contact is here. Everywhere contact is there. So everywhere normal is there. Okay, understood. So normal is in this like this. This is a normal. Okay, clear. So these are the normal forces. Understood. So if you add all these normals, so friction is acting here, Friction is acting here, 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 here. All the points friction is acting. So what is the maximum friction? What is the maximum value of friction? You know it. Mu s n, correct? Correct. So it will act upward. Mu s n will act upward. Mg will act downward. What is the acceleration I want? G by 3. So mu s n minus mg is equal to ma. So now solve. So mu s is 0.8. So 0.8 n is equal to mg plus mg by 3. So how much? 4 by 3 mg. So what is the normal value? 4 by 3 mg by 0.8. 0.8 n is equal to this. Okay, understood? So this is 40 by 3 into 8, correct? So 40 by 8 how much? 5. 40 by 8 5, 5 by 3. 5 by 3 mg. Okay, clear? So how much normal force I am exerting? 5 by 3 mg means 1.67 mg. 1.67 times mg. Okay, clear? And mass is given 80. So 5 by 3 into 80 into 10. 5 into 8 40. So 4000 by 3. Okay, clear? This is your answer. How much normal? Find minimum normal force exerted. 1333.33 force. Okay, so this much force I am exerting. Okay, so normally where you see the person is climbing the pole, circus. In circus maybe you will see. Okay, circus. What if you put lot of oil in this lubricants? Oil, person can climb it. If oil is there, lubricant is there, person can climb it. No, because friction will be not there. Understood? If you put oil here, oil or grease you put lubricant. Okay, so friction will not be there. So person cannot climb. Person cannot climb. Okay, clear? Person cannot climb. So note down. This is a good question. Note down. Now let's discuss cycle. So cycle is also important. Generally I discuss this in rotational motion, bicycle. So I'm drawing cycle now. So just imagine cycle you see. What you see in cycle? Cycle means tires, right? Two tires. It is made up of wood or rubber. Rubber tire, correct. You can fill air in it. Air is there, okay? Pump. You are filling air. Spokes are there, correct? Spokes. Spokes are there. Okay, fine. Now, these are two tires. Now, what else? Pedal. Okay. So, pedal, let's draw one pedal here. So, okay, okay, pedal is there. Now, what else? Can cycle move now? Chain, very good. So, chain is needed. But where you connect chain? Front wheel or back wheel? Back wheel. Okay. So you need one what you call it sprocket. What do you call it? Sprocket. Okay. It looks like this, right? It is like a circle disc with a teeth. You call it teeth. teeth. This. And here it is a small, right? One small is this. Teeth are there like this. Here also teeth are there. But can cycle move now? Can cycle move now? No. You have to connect it with chain, correct? Now connect it with chain. Okay, connect it with chain. Can cycle move now? Tell me. Can cycles move now? No. If you make pedal, your this wheel will rotate, but this wheel is not connected. So you have to connect it. Connect both the wheels. So you need one rod which will connect both. Okay. You need rod which will connect both. And this also it cannot be in air. It cannot be in air. You have to connect this also. Okay, like this. Clear? So this is iron rod. It is very strong rod. Strong it is. It is connecting both front wheel and rear wheel. And this is support. So this is the wheel. Okay. So now can I say that cycle will move? Can cycle move? No. Now person will sit here. Suppose one seat is there. Seat. Okay. Seat is there. So now person will sit here. So okay. And handle is there. Correct or not? Handle is there. The handle. Correct or not? Oh, one hand is more. Okay. You understood? Okay, fine. So now what this person will do? What this person will do? It will pedal it, right? It will pedal it. So this will move. So chain is there. So this will also move. So this person is providing torque. This is known as torque. When you rotate something, what do you call? Torque. So this will provide torque. So it will rotate. Now this is the ground. This is the ground. Now look at 2 points. A and B. A and B. A is in which object? Point A is in which object? Ground or tire? Tire. B on ground. Now this will rotate. Like this it will rotate. So A is going where? Right or left? Left. So A is going left. So B will exert friction on A. Where? Right. So friction on A is right. Understood? So rear wheel. What is this wheel? Rear tire. Rear wheel. So when you pedal, when you pedal cycle, rear wheel is rotating. How it is rotating? Clockwise. Clockwise. So lowest point. Lowest point. Lowest point is going where? It is rotating clockwise. So lowest point is going where? Left side. So ground will exert friction where? Right side. So this is the friction. So friction is helping it. Understood? So this friction is helping the rear wheel to go right side. Are you getting? So friction F help a cyclist to move forward. This is forward direction. This is forward direction. Okay. So cyclist will move forward. Understood? So this rear wheel is moving forward. What about front wheel? Now front wheel is connected with the rod. So this here, the rod is here. So this point will move right side. So the whole wheel will move right side. So this wheel is not experiencing torque. It is experiencing force here. It is experiencing force like this. It is experiencing force. So friction will act backward. Okay, friction will act backward. Note down. So it is also important point. It is given in NCERT or not? You check it. Okay, I think given in NCERT also it is given. So when you pedal your cycle, you want to accelerate. You want to accelerate means speed increase, speed increase. So you pedal your cycling. So rear wheel. What is the direction of friction? Forward. Understood? So friction is forward, but front wheel. What is the direction of friction? Backward. So both these frictions are equal and opposite or different? Different, correct. Otherwise cycle cannot move. If F1, F2 are equal, 1 Newton, 1 Newton, cycle cannot move. So F1 is greater than F2. Understood? So how will you find acceleration? F1 minus F2 is equal to ma. M is the mass of cycle plus person. Person plus cycle, both together. Okay. So M is total mass. M is total mass of cyclist. Cyclist, this person is cyclist and plus cycle. Cyclist plus cycle. Okay, understood? Cyclist plus cycle. Okay, clear? Okay, done. So what type of friction it is? If there is no slipping, no slip. So what type of friction? No skidding. If no skidding, skidding is like this. This is skidding. Okay. Now arrange one tire also. We need tire. Okay. Tire. You try to arrange. I will tell them. Okay, because we need it. Okay. So if no skidding, what type of friction? Tell me. Static friction. So friction is static. Okay. Not down. Friction is static. So static friction. Here also static friction. Okay. So cyclist is over. Pole is over. Okay. Clear. So now you little bit. We have discussed about friction. Now we are going back to circular motion. Okay. So note down. So we'll continue circular motion. So what here we are doing yesterday? Vertical circular motion. Okay, fine. Now next you write down rotating rod. Rotating rod. Rotating rod like this. It is rotating. Correct? When I move this pen from here to here, it is rotating like this. The fan blades are also rotating. You have any rod, any scale you have? Scale you give. Okay, that is better. Okay, this is the rotating rod. Rotating rod like this. Okay, it is rotating. It can rotate vertical. This is vertical rotation, correct? This is horizontal. So horizontal rotation. So note down. Horizontal rod. One end fixed. One end fixed. Like this is the rod. One end fixed. This end is fixed. So like this it is rotating. Okay, understood? This end is fixed or moving? Moving. What type of motion? Circular. It is going, see, it is going from here to here, correct? Circular motion. This end is not, this end not going, it is at rest. So one end fixed. This end fixed. This is fixed end, okay? This is fixed end, not down. Now it is rotating like this, omega. Okay, it is rotating like this. It is rotating like this. So you have to find what is the tension at x distance from the fixed end? What is the tension? What is the tension at x distance? It is horizontally rotated, okay? It is horizontally rotated. You can experience this. Suppose you are rotating your hand like this. You are rotating. Okay. You feel that your hand is pulling your body like this. You feel it? Huh? You can try it, but don't hit your other neighbor like this. When you rotate your hand like this, very fast you rotate. Do you experience your hand is pulling your body here? You experience it? So pulling your body, correct or not? See, when I rotate this object, it is pulling my body here also like this. So that pull force is known as tension. If you consider this point, is there any object on the right side of this? No. So here tension will be zero. Here tension will be zero. Okay, understood? I can give one more example. That pen is there. Pen is there. Okay. This is the cap. This is the pen. Okay. Now I will put the cap here like this. Now I am rotating it like this. The cap is attached. It is not falling. Now I will lose grip here. I will lose grip here. Now grip is less. Grip is less. Understood? Now what do you think? If I rotate, it will fall. Correct? See? See? Correct? So why it is falling? Tell me. Why it is? Because when you rotate it, when you rotate it, when you rotate it, there is a force acting. Where the force is acting? Where the force is acting? Where the force is acting? Away from center. You can call it center. Force is acting where? Away from center. So what type of motion it is? When you do circular motion, correct? When it is doing circular motion, when it is doing circular motion, what is the direction of force it is experiencing? Away from center. Are you getting? You are experiencing force away from center. So that is centrifugal force. What you call? Centrifugal force. So same thing happens with your hand also. Suppose you are rotating your hand. Okay. So your whole hand is experiencing centrifugal force. Right side, away. Understood? So because of that, tension is there. So on the right side of this point, there is no object. So there is no centrifugal force. So tension here will be zero. Here tension is zero. Where tension will be maximum? At the center. Tension is maximum. Tension is maximum at the center. Note down. The rod is rotating like this, horizontal. Horizontal rod is rotating like this. Okay, horizontal rod. So where tension is maximum? At outer end or center? Center it is maximum. Okay. Now you have to find what is the tension at x distance. What is the tension at x distance? So now consider very small point, small object of length dl, dl, and distance of this is L. Okay, distance of this is L. So what is the formula for centrifugal force? It is mr omega square. Note down mr omega square. The formula is same as centripetal force, but direction is opposite. It is a pseudo force. Centrifugal force is a pseudo force. Okay, what is the direction? Away from center. It is away from center. And what is the formula for it? Mr omega square. So now this is very small part of the rod. The mass of this small part is dm. Mass is dm. Okay, dm. Small part dm. Total mass will be capital M. So I can say capital M is equal to integration of dm. Are you getting or not? dm plus dm plus and so on and so on. So you will get total mass. Where is the first dm? Here. Last dm? Here. So what is the centrifugal force on this? Centrifugal force on dm, tell me how much centrifugal force on dm? Df is equal to dm. What is the distance from center? Radius L. It is rotating like this. Okay, so dm is here, this is L. So dm L omega square. Okay, clear? And the length of dm is dl. So dm by dl, we can write m by L. L is the total length of the rod. Note down. L is the total length. L is the total length. And mass of the rod is m. Total mass is m. So it is a uniform rod. It is a uniform rod. So total mass by total length is equal to dm by dl. So what is dm? Total mass by total length into dl. So substitute what is df? What you get df? M by L dl into L into omega square. Are you getting? So m by L, now you have to do integration. So m by L omega square L dl. So this is df. Okay, clear? This is df. So this is the centrifugal force on this part. Only this part. Now I want centrifugal force on this part. That yellow part. So you have to integrate. So total means net centrifugal force. So net centrifugal force on shaded part. You can call it A, B, C. Means I am talking about BC. So what is the net centrifugal force on BC? So this dm, if you consider dm here, this dm here, so what is the length? What is the distance? X. If you consider dm here, then what is the distance? Distance from center. What is it? If dm is here, what is the radius? Distance x. If dm is here, what is the distance? L. Okay, so you have to integrate it. So net centrifugal force on BC, integration of m by L omega square L dl. Okay, x to L. So this is m by L omega square integration of LDL. Okay, now integrated LDL. What is integration? What is integration of LDL? Integration formula x power n dx. What is this? X power n plus 1 by n plus 1, correct? So what is x dx integration? X square by 2. So LDL integration L square by 2, correct? Now limits, you have to put limits x to capital L. X to capital L. Now substitute limits. So we will get net centrifugal force on BC. So net centrifugal force on BC m by L omega square. 2 is also common. L square minus x square. Okay. So this is the net centrifugal force. Net centrifugal force on BC. M by L omega square. L square minus x square by 2. Understood? Note down. Copy this. So where is that cap? Cap, you got cap, anyone? Cap. So what? Now I am putting it very tight. Now I'm rotating very fast. It is not coming out. Why? It is not coming out. Why? Omega. If I move slow, omega is less. Now move fast, omega is more. Correct or not? When omega is more, centrifugal force is also more. Correct or not? So centrifugal force is acting where? What is the direction of centrifugal force? Away from center. Now look at this part. Look at this part. What is the direction of centrifugal force? Away. Centrifugal force. Okay. So like this. I'm moving it on this cap. On this cap, centrifugal force is this way, but it is not going. It is not going. Why? Because tension is acting. Tension is acting where? Here. Tension is acting where? Towards center. Are you getting? Tension is acting where? Towards center. Okay? Towards center. Same thing your hand also. Suppose you are rotating your hand. Why your hand is not detaching, breaking? Why your hand is not breaking? Tell me. This is your hand. You are moving your hand like this. Why it is not detaching here? Huh? If this grip is less, now it will detach very easily. Okay, like this. See, it is detaching. So why hand is not detaching? Tell me. Tension. There is a tension here. Are you getting or not? Whole body is holding the hand. The tissues are there. Muscles. They are holding each other. Holding each other means pulling or pushing. Pulling. They are holding each other. Okay. So hand want to go away. When you are rotating like this, hand want to go away, but your body is holding it. So this BC want to go away because of which force? Centrifugal force. So AB will hold BC. So AB hold BC. So that hold means what? Force. So AB exert push or pull force. AB is exerting push force on BC or pull force on BC? AB. Pull force. AB exert pull force on BC. Understood? And where? At which point? At B. So that pull force is tension. Understood? So this is tension force. This is tension force. So what is the formula for tension force? Tell me. What is the formula for tension force? This is the formula. Okay, note down. So it is very easy only. You just m omega square by 2l l square minus x square. You memorize this. Okay. Tension at distance x. Tension at distance x. So now you solve this question. Apply that formula. This rod is rotating like this. So horizontally it is rotating. Okay. But board is vertical. So I'm drawing like this. It is horizontal. Okay. Imagine it is horizontal. Now, what is the tension at midpoint? At midpoint, what is x value? Midpoint, what is x value? L by 2. So 2 points I am giving P and Q. P is the midpoint and Q is where? L by 3 from other end. So what is x value for Q? What is x value for Q? This is L by 3. So how much is this? This is x-axis. Tell me, if you walk L by 2, you will get midpoint. How much you have to walk to get Q? How much? This is L by 3. So this is how much? 2L by 3. Correct. 2L by 3. Okay. L minus L by 3 means 2L by 3. So x value is 2L by 3. Okay. So what is the ratio of tension at P and Q? That is the question. Find tension at P and tension at Q, and ratio you have to find. Ratio. So this is the formula. M omega square by 2L L square minus x square. Use this formula. So what is tension at P? Tell me. Use the formula. Tell me what is tension at P? Use the formula. M omega square by 2L L square minus x square. For P, what is x? L by 2. So what is x square? L square by 4 divided by. Now Q, M omega square by 2L into L square minus, what is x value for Q? 2L by 3. So 4L square by 9. So M omega square by 2L cancel. M omega square 2L cancel. L square common. 1 minus 1 by 4 divided by L square common. L square common. 1 minus 4 by 9. So L square cancel. Final answer, tell me. 1 minus 1 by 4 how much? 1 minus 1 by 4? 3 by 4. 1 minus 4 by 9? 5 by 9. 3 by 4 whole divided by 5 by 9. Tell me what I write, tell me. 3 into 9 will go where? Numerator. 3 into 9 divided by 5 into 4. 27 by 20. Okay, 27 by 20. Okay, clear? So note down. Give me the book. We'll see one question like this. Any question is there? Okay, so that This is rotating rod. What is the topic? Rotating rod. Maybe it is in rotational motion. We will see. I think it is in rotational motion. Okay, maybe it is in laws of motion. Okay, so this question is not there in this. Okay, it is not there in the book. Okay, no problem. So centrifugal force you have understood. Okay. So okay, take break. We'll continue. Okay, we'll continue.